स्क्रीन शेयर करछि।
हाँ स्क्रीन शेयर
देखा होला।
हाँ हाँ
ठीक अछि।
हाँ भाई ना
Anyone?
Balaji, this is Partha. What I understood is big data is technology which is used in massively parallel processing system and which can handle a huge amount of data. Mostly if we can go for unstructured data. Yeah.
Okay. Anyone else? That's a good definition, Partha. And will it is your understanding somehow is correct? Okay, and we'll learn more. Next one.
This is Maya. Yeah, so big data is process of managing high volume, velocity, and variety of data. So basically, we manage unstructured and structured data here. So that's what my understanding.
Okay, good. Thank you. Okay, so we had couple of definite understanding or the thoughts over big data, right? Okay, let's start with the introduction to big data. Okay, so I'll start and we'll go with the definition first. Then we'll discuss more on big data and our understanding. Okay, so I'm proceeding with the next slide. Okay, which was more like a book definition. Okay, so I have put here more like 3 major sources where people normally very often refer to the stuff. Okay, first is wiki. So what wiki says about big data, it says big data is a term of data sets that are so large or complex that traditional data processing applications are inadequate. Okay, so as per wiki, it says it's a problem. It's a problem with processing the large volume of data. Okay, then another media partner with Gartner, what it says, big data is a high volume, high velocity or high variety of information assets that demand cost-effective, innovative form of information processing that enable enhanced insight, decision making and process automation. So it's quite impressive. See, when it says high volume, high velocity and high variety information assets. Okay, so when a data turn into information, any ideas who are from the BI background? So let me explain. We get a lot of numerous data from our current world, right? In different variety of form or different data, we get it from different sources. When we are able to understand the data, its meaning, and we are able to derive our business needs out of it, then we say it's information, right? So what it says high volume, high velocity, high variety information assets, okay, that demands a cost effective, innovative form of information processing. Why cost effective? Because we see all the high terms, right? High volume, high velocity, high variety. Okay, so if we use our normal traditional systems, it would be more costlier to process this data and to get the insight or make the decision out of this data. Okay, so why it's so, we'll see on the next chapter when we move forward. Okay, but as of now, just consider it. It's a very high volume, high velocity and high variety of information that requires a cost effective processing solution, okay, to get the insight out of it. That's what Gartner says. Okay, so O'Reilly is another media partner, is a major publication, I would say, it publishes major books in the market, right? So what it says, big data is the data that exceeds the processing capacity of conventional database systems. So why it says like it exceeds the conventional database systems? Because the conventional database systems, right, like Oracle or DB2 or SQL Server, right, they have some limitations. Limitation, what's the limitation? Like if you say Oracle, right, it cannot process more than 12 terabyte of data. Okay, it has its own limitation. Similarly, when we go to SQL Server, it has 18 terabyte of data. Okay, and beyond that, it cannot process it. Okay, the system has its limitations. Okay, and what it says, the data is too big. Too big means definitely it's more than 18 and 20 terabyte, right? Definitely. Or too fast. Too fast means that in a traditional system, the way data arrives, okay, the velocity on which the data arrives. So this big data is much faster than the traditional system. So how it is, we'll see in the next chapter. Okay, when we proceed with the next slides, we'll see the velocity. We'll measure the velocity. Okay, and it doesn't fit the structure of the database architecture. So what is the database architecture? Database architecture means any database architecture, when we say, is like nothing but a schema and data. Okay, the schema are the logical convention we fit on top of data to read the data, right? So the big data doesn't fit always to the database architectures. Okay, so in order to gain value from this data, we must choose an alternative way to process it. Okay, so any question so far? Any question, guys? We are okay to move forward?
Yeah.
Yeah.
Okay, so overall I'll summarize this page. This page says big data is a very big data which need a special kind of processing. Okay, we'll see in the next. So when we are defining the data, right, from the, like, guys who are not speaking, could you put in mute? So in traditional system, or from the defining a data from a we'll see from the how it starts, right? It starts with a bit. Bit is nothing but one placeholder in the memory which can store either 0 or 1, on or off voltage, right? And the top of it comes a byte. A byte is nothing but it's enough to store or create a number or an alphabet. Okay, so that we know from the before, and we know from a long time, okay, what is a byte, right? Then we know on top of byte we have a kilobyte. This kilo, the word in Greek is 1000. Okay, and when we say kilobyte, exactly what we imagine, my understanding is, when I say kilobyte, is 2 pages of text. If I do a printout of like 2 pages of text, the amount of words or letters that will fit into that equals to a 2 kilobyte data. Okay, then we have a megabyte. Megabyte is like a little larger than kilobyte, right? And if we define in a real world scenario, it's like if, like Shakespeare, the famous writer, the very well-known writer, right? On his whole lifetime, whatever the things he has written, right? If we make it a digital form, it will be like worth of 5 MB. Okay. And in early days, right, 5 MB was a very big chunk of data. Okay, I would say in early 90s. Okay, 5 MB is a big chunk of data. Okay, then slowly we come to gigabytes. Okay, gigabytes means in Greek like it's a giant, like even more than large. Okay, which called like giant. It's typically like when we see a movie, right, in HD format, any movie, right, it plays like almost 1 to 2 hour movie, right, and it holds like 1 to 2 GB of data. So this is how till now we are defining the data, right? So in future, how the data looks like? In future, the data will start from terabyte. Okay, terabyte means like in Greek, it's meaning like monster. Okay, and if we define in real world, like we have US library, right, of Congress, right, where like all the book publications are there, right? It's a very big library. Okay, if we make all the copy in digital format and we'll store it in a database or any storage, right, it will occupy 15 terabyte of data. So it's a quite big amount, right? 15 terabyte. But still, hold on. Like if we say Google is the like, they are the pioneers in holding the big data, right? So if we say Google, every per hour it processes almost like 24 petabyte of data. So what is the petabyte? Petabyte means 1000 terabyte. 1000 terabyte. See, whole US Library of Congress, right? It has 15 terabyte, right? And the petabyte is equivalent to 1000 terabyte. And the Google process 24 petabyte data per hour. Okay, so that's really very challenging, right? Am I clear? Are you able to realize the problem? How big is the problem? Am I clear, or like any?
Yes, Balaji. Yeah. Yes, Balaji.
So realize now, right, how the problem is growing, right? Let's say our conventional system will say, okay, or like we have a very good, very efficient process, okay, system, okay, which is giving a phenomenal like result. Now, can you imagine how long it will take to process 24 petabyte of data? Anyone? Anyone can answer? In a normal system, right, when we process 1 terabyte of data, right, to read the data from the disk, right, it takes almost 2.5 to 3 hours. Okay, so imagine 24 petabyte data, how long it will take to process. It's really difficult to imagine, right? But still, the problem doesn't stop over here. Okay, we have the exabyte. Exabyte, like it equals to 1000 petabyte. Okay, 1000 petabyte. So let's say a weekly magazine, The Economics, right? 10 billion copy of a weekly magazine. If we make it digitized form, it will become a 1 exabyte of data. Okay, or 1000 petabyte of data. So how this is related now? A weekly magazine. Let's say tomorrow one app will come, it will say worldwide all magazines, digital form it will host. Then how much space it require, right? All publications throughout the year, worldwide all magazines, make them digital, keep it. Definitely it will need a exabyte processing system, right? A system that can process the exabyte of data. Okay, now let's say even exabyte, more than we have zettabyte. Okay, 1 zettabyte is 1000 exabyte. 1000 exabyte, which is beyond our imagination, right? So the market research or predicted company, right, what they predict, the whole total info exists in 2010 is equals to 40 zettabyte. Okay. If any company wants to utilize all dimension of information exist in today's world, right, he has to go in zettabyte, right? He has to have a processing framework which can process the data in zettabyte, correct? The next is yottabyte. Okay, yottabyte like is 1000 zettabyte. Okay, when we move on, like it's kind of the data amount are going on increasing. Okay, and with the growing data we can realize how the problem or the challenges to process the data. Okay, you imagine that prospect. When I say this count or the definition of defining the data measurement, it's not about, I'm not telling you to how to measure the data. I'm just trying to make you understand how big is the problem and what are the challenges to resolve this problem. Okay, think in that perspective. See, people who are working in mainframe system, they can easily realize how big is the data and how mainframe is a, like, it's, we think of mainframe is very efficient and very, like, it's processing a large volume of data, right? Even people who are working in BI world, right? BI, like, we are dealing with numerous data. We are doing, like, when we create the data sets, like for the analysis purpose, like cubes, or the, when we create the SAS cubes, or we create the we do the slice and dice of the data, right? It's a huge volume of data we are dealing, but still when we compare with these sizes, right, those data are nothing, right? Those data are nothing. So imagine like how much processing power or capacity a company will need to process this data, right? So it's really challenge, right? So this is what the big data is. When we say big data, means it's definitely of the size either petabyte or hexabyte. If we are able to imagine a system which can receive this amount of data, okay, terabyte, petabyte, or exabyte data, we'll say definitely it need a big data system or the Hadoop system to process the data. Okay, why it is so? The question is there, right? So let's leave the question over here. Okay, we'll find the answer in the going forward in the next slides. But this is the open question. Okay, how to process this such big data? Okay, so I'll move. Any questions so far, or we are good to move forward? Are we good?
Yeah.
Yeah.
Okay. So, is it interesting?
Yeah, very good.
Okay. So we know now, like we are now, like, just we have seen like how a big data is, right? When we say big data, how big it is, right? How big it can be also, right? We have seen. So different companies are like the leading market market leaders, or the market, I would say the market leaders who are working on these solutions, they have defined the big data with their characteristics. With the characteristics means when they see the data, they analyzed all the data and they found some common characteristics among the big data. Okay, and they defined, and we can say any data as a big data when we see these characteristics on the data. Okay, so these characteristics are volume, velocity, variety, and veracity. Okay, though the veracity is very new phenomenon and it's only limited to the business user who are using the data, but this is also one of the characteristics which introduced by the IBM. Okay, this veracity characteristics is being introduced with the by IBM. So when we say volume of the data, we just realize, right, when we say 40 zettabyte data, we can imagine how big it is, right? When we say 2.5 quintillion bytes, the quintillion is nothing but zettabytes, okay, 2.5 zettabytes of data. That also, like, we can see like how big it is, right? And in the, let's say we have 6 billion people who are using the smartphones, and the data comes out of the smartphone. If we get all the data and we'll see, it would be very big, right? So that characteristics defines the volume of or the scale of the data. Okay, so any traditional system will not fit to store this data, definitely, right? Even if we try to store the data, it will take numerous days to store the data. And reading the data also a big problem. Processing is different thing. Just to store, write and read would be a challenging, and we cannot do it with the traditional system, right? Then we'll see the velocity. The velocity means how fast the data is getting generated. Okay, so when we go and see New York Stock Exchange, right, it generates almost 1 terabyte of trades. 1 terabyte of trades information every day. Every day it generates 1 terabyte. Okay, and when the analysis, the people they do the analysis, they refer to like 10 years, 20 years of data and see how big is the data, right, and how fast it is increasing. Every day 1 terabyte, how fast it is increasing, right? So if we say, let's say 1 terabyte of hard disk I'm having, every day I have to plug in a new hard disk to get the data, right? And 10 year worth of data means like I'll have a room full of hard disk, right? So the velocity is very high, right? Similarly, in future car, right, which is like autopiloted car, the future autopiloted car, right, they're supposed to have like almost 100 sensor in it. 100 sensor, it will monitor every occurrences around it, right? Like it will see that it's called like M2M or M2I information. What is M2M? Like machine to machine. When it encounter a machine around its surrounding, it will send the data to that machine. It will collect the data from that machine. Okay, so it's called M2M data. Okay, so see, when a car drives a 1,000 miles, how many machines it will interact, right? And how many data signals it will generate. Can you imagine? It's very large, right? And we have like number of car in US. If we think about how much data they will generate and the way they generate, right, every day how much data it will get generated. Can you imagine? Can you imagine that? That's a big data, right? A very high volume and velocity data, right? Then we'll come to variety. Okay, variety means we have different kind of data, right? Different kind of data, like we get the data from social media, we get the data from video messages, we get the data from sensors, we get the data from like server logs. Okay, all different type of data are there, right? If we classify all this data, variety of data, right, it will be classified into mainly 3 categories. One will be structured data, one will be semi-structured data, and one will be unstructured data. So all these 3 categories of data we'll see in detail in next sessions. Okay, but for now just understand what is a structured data. A structured data is something which has a schema defined on top of it. We can refer the schema to understand the data. That's called structured data. Okay, like an address. right? Address, my home address, right? When I say my street address 265 Slater Street, right? That means we are able to imagine, okay, the street name is 265, right? That's it. Street name is a schema and the value is 265 Slater Street. So any data associated with a schema or the definition of the data, right, or metadata, sometimes we call metadata, is called a structured data. Example, one Excel file, one text file, one XML file, one RDF file, right? All these data are called the structured data. They have a specific pattern of occurrences, right? Then we'll come to semi-structured data. So what is semi-structured data? Semi-structured data is like a data which has a schema associated to it, but to interpret or to understand the data, we need to have a special kind of processing or methodology to understand it. Example, GPS signal, right? GPS signal, it can be decoded or can be understood by a GPS device, right? Or a sensor data. Suppose we have a temperature sensor, right? A temperature sensor data can be understood by a specific device only, right? It cannot be understood by a universal system. Any system it cannot understand. It should have a interpreter to interpret the data. So those are called as semi-structured data. Okay. Then we have unstructured data. Unstructured data means there is no form of it, like an audio clip, a video clip, right, or a geographic location, right? These all are like unstructured data, or we'll say there's no form of it or no schema of it. No, and to interpret it, we have a different altogether methodology to do it. Okay. So as of now, we just understand the variety of the data. Now veracity. Veracity is uncertainty of the data. Uncertainty of the data means we'll extract a huge volume of data, but we are not sure how much of that data is useful to us, right? And to cleanse the data, there will be more expenditure to clean the data. Okay. So there was a research, they have said like almost like that poor data quality in US companies, right? It costs around 3.1 trillion a year. Okay, $3.1 trillion a year. Okay, so that's very like worried reason. We should know when we are capturing the big data, we should know the data which we are capturing is useful to us, and we are able to understand the data, and we can derive some of the insight out of it. Okay, or else we'll say it's totally garbage data, right? So the veracity also there. Okay, so now we learn like volume, velocity, variety, veracity, right? These are the characteristics of big data. So any question so far?
I have a question, like this veracity of data is just to remove the data from the like from the data volume, or like how will define the veracity? Because
Veracity is like, see, we have thousands of source of data, right? Before we onboard the data, we have to think about which source we have to take, whether I'm able to derive any insight out of it. Let's say, example, let's say you have a Twitter account, right? You have a Twitter account.
okay.
And you are capturing like some of the words, like let's say terrorist or a like firing, or a you are capturing a word like bomb blast, right? All this you are capturing, right? But when you capture, there are a lot of uncertainty data will also come along with it. Let's say you are staying in US, okay, but there is an incident in Paris, right, which is nowhere related to you, but those data will also come into you, right?
Yeah.
So the veracity is there, right? You have to understand the veracity of the data. So veracity is also one of the characteristics of the big data, because when you are capturing the data, right, big volume of data, there will be certain veracity or uncertainty of the data. So you have to understand that. Am I clear?
Yeah.
Thank you. Any more question? Shall I move to the next session or next page?
Yes, Balaji.
Thank you. So we saw this velocity, volume, velocity, variety, veracity, right? Now we'll see this. We already said like veracity is limited to the business user who are using it or who are trying to get the insight out of it, right? So the remainder like volume, velocity, and variety. So how this data come into the real world, right? It looks very interesting, but we don't know like which scenario it's getting generated, right? Let's say volume. So in my slide, if you see, this is like nothing but a PNW 100G GTF jet engine, okay, or Boeing engine, whatever we call, right? So this is like one of the main part of a aeroplane, okay, which gives the thrust to take off the aeroplane. So it's a very critical part of the aeroplane, right? And this engine has almost like 5,000 sensors, which monitors different kind of parameter, 160,000 parameter. It monitors 160,000 parameters, this 5,000 sensor. So when they emit the data, from the sensor to the hub where the data is get collected, right? It generates 1 terabyte per second or 3.6 petabyte per hour data. Can you imagine one plane, right? If it flies for an hour, right, it generates almost 3.6 petabyte per hour data. Okay, so to process this data or to collect the stats of this data, right, and to see the visualize the data, does also need a very quick response, right? So we definitely will need to have a very different system which can easily process this kind of data in a quick and very swift manner, right? So this is one of the example, okay? Then we have another is Google, very famous. When we said big data, we cannot stop using the word Google. Google anyway, we have to pronounce it because they are so much associated with the big data processing. Okay. So the next example is Google. Okay. So Google, what it do, we every day we do any like it's very common thing like we go for like Google search for each and everything in our day-to-day life, right? If you want to know anything, ask Google. We want to see a sample coding, ask Google. We want to see a new concept, ask Google, right? Google is very phenomenal in providing you the fastest result, right, and accurate result. So if you see the all these requests, right, Google worldwide it receives almost like 3.5 billion searches requests per day. 3.5 billion search per day, okay, and it has almost 1.2 trillion searches per year, okay. All these requests, right, it processes almost like 24 petabyte data per day, okay. So 24 petabyte data per day means it reads and display the data to the users, right. Also, the way it creates and maintains the data, right, for that they have a different algorithm, and the very basic thing is the crawler. It almost like every day it crawls 20 billion sites and it creates the indexes, okay, so that when you hit it, it will give you the accurate information and is very fast information, right. So that's like volume, that kind of volume they are dealing with every day, right. Next is our future car, like Tesla is very famous car, right. Like everybody should, like in the market, everybody is talking about Tesla, right? Autopilot, it has everything, like you'll have a different level of car experience, driving experience, right? So how this they make it possible? Because like over the period of time, right, they analyzed all the data generated from the car, okay, either from M2M or M2I. M2I is machine to infrastructure. When a car goes, it find a like speed limit, right? Speed limit symbol is there, right, in the highways. So how it detects it? Because there is a kind of signal called machine to infrastructure, okay. Any infrastructure around it, right, it will do, if it hit, it will recognize, okay, this infrastructure is for this purpose, right, and it will identify the lane of the road also, right. How it do is it, how they do it? Because of big data processing only, right. And all this, right, they have almost like 100 sensors inside it in a car. It generates like 1 GB data per second, okay. With all this machine to machine or machine to infrastructure data, it generates like 1 GB data per second, right. And the interesting fact is, an average American drives like 600 hours per year, okay. So imagine for a single driver how much data it generates, right. So it generates almost like 2 petabyte of data per year, okay. So how big is that problem? See, so why they are generating so much data and why they need it? Because they do the machine learning. Machine learning means they create a system which recognize a pattern and take action, right. So for that they need all kind of patterns, right. They have to build a repository of all the patterns, right. So for that they need each and every information. So how critical it is, right. And when we see the volume, it's very high volume, right. Am I clear? Any questions so far? Any question? Are we good?
Yeah, we can go ahead.
Yes, please go ahead.
So are you people finding interesting?
Yes.
Okay.
Yes, Bala.
So like ask as much as question you have, okay? And we make it interactive, right? We can discuss more topics, okay? Then we'll go ahead with one of the major entertainment leader, or we call the Netflix, right? They have a lot of thousands of content in the web, right? You can watch the HD movies. So can we ever any time like we have realized, like if you watch a single movie, right, it almost consumes 3 GB per hour data. So we realize like we are only watching a 1 hour movie which is hardly one or 1.5 GB of data, But what about another 1 and 1.5 GB data? So that data Netflix collects during you watch the movie. During the watch the movie means collect each and every step you do, where you click on the site, they collect everything. Okay, they do the clickstream analysis, they do where you paused, where you forwarded, everything they watch it to make you or improve your experience, movie watching experience. Okay, what sort of movie you're watching, and like what are the recent movies that can make you more happy to watch. Okay, so to improve and the quality of data transfer between your device to their server, right, they always all this they analyze it. So that whole data, right, they keep it on their server as well to improve the customer experience. So even like if we leave their data and we consider only our data, okay, what we are watching, right? An average user on an average, like it was like 45 GB of data per month, right? And Netflix has 60 million users, okay, and altogether it generates like 3 exabyte of data per month. It process, it reads, and it display the content, okay, 3 exabyte of data, right? So imagine how big is their system. When you go on Netflix, have you ever realized it's like slowness or it's not responding properly, right? But at the same time they maintain the customer experience at the same very high level, right? How? They have a very big system to process this data, right? Which we'll discuss on a later stage. Got it? Volume is clear? Are we clear on the volume part? Big data, when we say volume means how the problem is. Okay, I'm moving to the next one, velocity. Velocity is nothing but how fast the data is arriving. Okay, how fast the data is arriving and how fast we have to consume, extract the information, and we have to respond, right? So if you see again, like we have all the medias like social media, YouTube, we have LinkedIn, like we have sensors, we have devices, we have all this data we have, right? It comes out of it. And when we look into like with specific to the companies, right? Let's say Google, which we saw it, right? 3.2 billion searches, 30 trillion unique URL, 20 billion site scroll. YouTube like per minute it's uploading 72 hours of videos per minute. In YouTube per minute they upload like 72 hours of videos. So how big a system they need to fast and keep the like all to satisfy all the users when they're uploading, all the data get received, stored, and when they want to access it, respond very fast, right? So that's called like YouTube, like 72 hours of video uploads per minute. Okay, in Twitter, right, worldwide everybody tweets for anything, right? So it generates like 500 million tweets a day. And when we say like Amazon, the e-commerce giant, right, it's processing 1.1 billion order a day. Even in Chinese Amazon, like Alibaba, is 12.1 billion orders per day. And if we leave all this, right, let's say smartphone, see this bar chart, right? We have like starting from 2010 to 2019, the US smartphone users, how they are increasing. And they're predicting 2019, they'll have almost like 236 million smartphones, right? It's almost like 15% more than what we have. So how much data they will generate? You know, like every moment of your smartphone is being tracked, the data will be collected. They are being used for the customer experience. right? So all this data will come and generate, like that's called the velocity, the way the data will get generated. Okay, am I clear on the velocity? Any question?
Yes, Sonat.
Okay, let's move. So the next is variety. Variety, as I said, like we collect the data from different sources, right? We collect it from social medias, we collect it from the Bluetooth, we collect it from the sensors, we collect it from the smartphones, we collect it from the laptop or tablets, right? We collect it from the smart watches, we collect it from any kind of devices, right? We collect all this data, right? So this data when we collect, right, they come in various forms, right? When I say like a GPS device, they talk the GPS signals. That's a very like semi-structured data, right? The kind of data they receive and they interpret, only a GPS device can only understand. Okay. Similarly, an RFID, like when say we say RFID, like or signals, right? They are being interpreted with the system, which are configured to interpret it. Okay, not like any system can interpret it. So those are the semi-structured data. And unstructured data, as I said, photo, videos, music, newspaper, or a handwritten note, everything is unstructured data. Okay, those are called variety of data. So this is like a company called Fastmark, okay, which maintains this landscape of the big data, as like it's very evolving. Every day it grows, right? Every day new system comes, new technology is coming. Every day new app is being built. Every day one new concept is being derived. So this company, they are making an effort to bring all this into one landscape and user can easily refer to it. Okay. So if you see this landscape, right, as for 2006, right, they have categorized all these landscapes into different areas. Like first, if you say infrastructure, they have all apps, softwares, or the any kind of companies that deal with the infrastructure, big data related infrastructure. They have listed out over here. Similarly, analytics, any analytic product which are available in the market, either is a it's open source or it's a like vendor product, right? All are listed over here, right? Then we have applications. The applications like all the applications which are built for a specific purpose, right? They are listed over here. Then we have the cross infrastructure. Cross infrastructure means like which can is proprietary tool which can interact with heterogeneous sources of big data and process the data. That's called cross infrastructure applications. Then we have open source. We have the tools and technologies which are available, ready to use with the open source. They are listed over on the right side bottom. Then we have data sources and APIs, and like all this, if you see, right, whenever you get some time, right, go and look each and everything, right? These are the buzzwords, right? You should aware of it. You should not know. It's not necessary you should know each and everything, but you should have a fair knowledge on what it is, right? So I would say like you on your free time you should go and see, just Google it, wiki it, okay, and you see all the things and you start knowing about it, okay. I'll continue, go to the page number 13. So okay, so far we have so far we have covered. We have covered like what big data it is, the characteristics of big data, then in the real life like how it comes, then we have seen the landscape of big data. Okay, am I clear? I'll continue with the computer architecture. Okay, so we have like different type of or different variety of computers available in the world, right? Like I'll say first start with our laptop or desktop, which is having a single CPU, RAM and disk. Okay, which normally which we call a single CPU computer. Similarly, we have SMP or symmetric multiprocessor, which we have like number of processor, one RAM and a couple of disk. Okay, they're attached to a LAN, and when we create a network of similar computer, this is called the MPP or massive parallel processors. Okay, so why I'm explaining this, because this is one of the foundational block of big data, okay, which we'll see on the next chapter. Okay, so a single computer, when we say like, when in our day-to-day life, even we have realized, right, we have realized, like, okay, we need more computational power, then okay, add more CPU, okay, add more RAM, add more disk, right? So that actually we are doing a vertical growth of the system, right? There is no horizontal growth. So this way we are able to meet certain level of needs, but beyond that, again, we have certain infrastructure constraint which we cannot do it, right? But to overcome that scenario or to overcome that situation, what we can do, we can add a network of computer to it, right? We can create the network of computer, and whenever we need more processing, just add a new network of computer, right? So that actually system is called massive parallel processing. Massive parallel processing. So currently available in market, right? If you see all like Teradata, Netezza, Redbricks, right? All these are like they are built on this MPP architecture, MPP or massive parallel processing architecture, right? So they have internally they have built this is like their proprietary of building the architecture. They have a network of computer which are being networked together to do a task. Okay, to do a task. So how the task is being executed? So instead of doing a task by a single computer, what they do, they divide the task and assign to each computer, right? So that's called divide and conquer approach. Okay, so from there the distributed processing comes, right? From there the distributed processing comes. So are we clear on SMP MPP? So these are the foundational blocks. Okay, you have to have very good understanding on it. Okay, any questions so far? Okay, I have one question. Let me see. Who is this? Sorry. Or could you read out the question? Sorry, I'm not able to see it properly.
I think it's question from Soumya, like does big data architecture follow MPP, like network for compute, network of computer, right? MPP.
Yes.
Does it follow by big
Yes.
data?
Right. So big data follows MPP, but different generation of MPP. Okay. We have different generation of MPP. We'll see in subsequent slides. Okay. So the Netezza or the Teradata, right? They are called like the first generation MPP. Okay. And little enhanced one is called the little enhanced one is called the next generation or the MapReduce framework. which is called second generation, and now third generation is the Spark or in-memory processing. So all these are MPP, but different generations. Okay, could you hold for a second? I'll just be right back. Sorry, my computer is running out of stand, so I'll just put power cord plug in. Yeah, now we are good. Okay. Any further question? Or we are good? If they follow MPP method like Teradata, Netezza, sorry, again I missed the question. Could you read it out?
Soumya is asking if they follow the same MPP method like TD, Netezza, then how is this processing different?
Right. So there are little different because Netezza, Netezza and Teradata, they are like their own proprietary tools and processing methodology, okay, which are very costly in the market, right? They charge a lot of amount of dollars to the customers to use it, right? But we can get a similar equivalent processing capabilities using this open source Hadoop. That's why people are more now preferring Hadoop because it's an open source, low cost environment. Okay, and these are more mature than this Netezza and Teradata, right? Netezza and Teradata, they are more like a vendor product, okay, and they have their own limitations, which they cannot do the new things like the image processing or unstructured data processing, which they have their own limitation. They cannot do it, okay. But this open system, they can do it, as well as they can fulfill the similar thing what Teradata or Netezza is doing, okay. Is it fine?
Balaji, this is Abhijit, just doing a time check. So,
Yeah.
shall we continue for some more time if all are comfortable, or? Guys, everyone is comfortable to wait for some time, or including Balaji, it's already 11:30 EST for the people in East Coast.
Yeah, we can like we have 5 more slides, so we'll take another more.
Yeah, we're good.
So Sambeti, to answer to your question, when I say the open source are cheaper because they use the commodity hardwares, right? So, but let me make it clear. When we say commodity hardware, it's not like our personal computer, okay? They are the same enterprise level hardwares, but with a lower price, okay? They don't need a very high skilled computers, okay. Okay, so I'll move to the next slide, or you have any question?
Yeah, you can move to next slide.
Okay, thank you. So I'm moving to the next slide. So how the distributed processing came into picture, right? So how the distributed processing came into picture? There, like there was a lady called Grace Hopper. Okay, she was serving in U.S. Navy. Okay, so she came with a very fundamental question. In earlier days, when a ox is not able to pull the cart, right? They're not going to bring a bigger ox, right? They used to bring another ox to pull the cart, right? So that same way, what she said, when we need more processing power, right, then instead of doing a vertical scaling, let's do a horizontal scaling. Okay, horizontal scaling means add one more computer rather than putting more CPU, more RAM into the same computer, which eventually after some time will have its own hardware limitations. Let's put more computer and do a parallel processing, right? And that idea actually triggered the distributed processing idea. Okay, the distributed processing idea. So initially they created a system which can centrally control and can execute the task parallel way. Okay, and that's from where the distributed processing started. So the characteristics of the distributed processing was initially like to have a parallel execution of task and independent failure of the component. Independent failure of the component means if one component fails, right, the other should not fail. Okay, they should continue on their own job. Okay, and single point of control. Single point of control means the job submission and monitoring should be from a single interface. Okay, those were the like characteristics from where they started developing the distributed processing. The challenges to implement it, the challenges were like, in order to submit a task and divide it among different computers, the programming complexity was there, right? And again, when they submit the job will be distributed among different computers, right? But how to distribute the data, how the system should know which data element it should process to enable the parallel processing capability, right? That's one of the challenges were there. Then once they process the data, even the individual process parallel, they process the data, right? How to collect whole the data amount and publish it as a single amount, a single result, right? That's also one of the challenge. Again, when they communicate each other, right? When the system or the network of ratios they communicate each other, there was a network bandwidth limitation, right? How to come about the network bandwidth limitations and handling partial failure. When we say the other component should be independent of a failure of a single component, but suppose a component has failed, then how to handle that partial failure? That means the component which failed, how to restart that component or how to recover that failure, right, from there only. That was one of the challenge was there. And also like they thought of, okay, we will do distributed processing, but how to store the data, during the processing or after the processing or before the processing, so that a distributed processing can be enabled easily. Okay, those were the challenges initially they identified in order to build a distributed processing. Okay, am I clear? Everybody clear on the distributed processing, what distributed processing is? Thank you, Partha. Yeah. So let's move to the next slide. So So over the period of time, right, the distributed processing has evolved much, and when the like giants like Google, Yahoo, they invested their own resource, they invested money to evolve the system, right? Because they need it was their problem initially, right? Yahoo and Google's problem, like to handle such big requests from the worldwide, right? So they invested more into the developing a distributed architecture or the process which can solve to their daily needs, right? So in 2004, right, Google has published a paper called Google File System. Google File System. So again, what is a file system, right? It's a very concept, like we know like what is a file system. It's a very basic part of a operating system, right? A file system, it manages the data, right? And it manages the user request to where to store the file, right? On where, how to display the data. All this information, is being like handled with the file system, right? So Google has developed a new file system. So currently we have different file system in the world, right? Like a, can you tell me a very known file system all of you know? Can anyone tell me like any file system name which you people know? Any file system you know? Very good. So Ashish says NTFS, right? So NTFS is a Windows file system, or is called New Technology File System, right? So Ashish, any idea like before NTFS what was there? DFS, no, right? FAT32. FAT32 was the initial file system Windows has developed, right? So after that, he developed the NTFS, which is like New Technology File System. So what's the difference between these two file systems? Any idea? Why Windows had developed a NTFS where earlier it was having a FAT32, right? So it's because of like the file size limitation, okay? So in FAT32 there was a lower file size limitation. I think it was like you can hardly create a file of size, I don't really exactly remember, but it's like almost 4 GB of size, okay? And in NTFS you can create up to terabyte of size file, okay? And because of the growing demand, they have created a new file system called NTFS, okay? Similarly, we have like in Unix we have ext3 file systems, right? And Apple has its own file system. It's called hierarchical file system, which again like IBM also uses the same file system, okay? So Apple has recently introduced a new file system. So all these file systems are there. So Google also developed one file system called GFS, or Google File System. So Google File System, the beauty of this file system is like other file system, right? They natively reside on the OS, okay? They directly communicate to the OS kernel and they solve the purpose of the request, right? But Google File System is, it sits on top of an existing file system. Either it's ext3 or ext4, it sits on top of that file system, okay? And it connects to the native file system, and the native file system in turn connect to the kernel, okay? So that is the first file system for distributed processing developed by the Google. Then in early 2004 this GFS paper was released, and later part of 2004 they released another paper called MapReduce. Okay, MapReduce is a a framework, okay, Java based framework. They released how to enable the processing of the data in a Google file system. Okay, then after that Yahoo has invested in Apache project, okay, where Doug Cutting, who was the person who was working on that project called Notch, and Yahoo has invested in that project and to work and fine tune this Google file system and MapReduce framework. Okay, then Doug Cutting, he developed this Hadoop file system, or called HDFS, Hadoop Distributed File System. Okay, Doug Cut has developed it, and he developed the processing framework called MapReduce also. Okay, and it was developed part of Apache Apache open source community. Hence, it's a free available free source free source. So it's anyone can use it. They can customize it and they can make their own distribution. Okay. So in 2008, they developed one system with 910 node cluster. Okay, they developed one Hadoop system with 910 node cluster, which eventually used to sort almost like 1 terabyte of data. Okay, and it made a world record to sort the data in just 3.5 minutes. So 1 terabyte of data, they just sorted the whole data set in 3.5 minutes, which is a world record till now. Okay, till now no one has no other process has achieved this performance benchmark. Okay, so that's called the TeraSort benchmark. Okay, so this TeraSort benchmark is being achieved by the Hadoop distributed file system, or Apache Hadoop framework. Okay, so from there onwards, everybody realized the capacity or the capability of the Hadoop distributed system, or Hadoop Apache Hadoop system, to handle big amount of data or the big data sets, how to handle it. Okay, and this Doug Cutting, he came out of this Apache. Okay, and they formed a new company called Cloudera. Okay, and in that Cloudera, they just customized this Hadoop distributed file system, and they called CDH, Cloudera Distributed Hadoop. Okay, so that was the a short story on how the big data history has been evolved. Okay, then we'll go into the next slide. Any question? Any question so far? Are we good? Thank you, Madhur. Yes, Samvit also good. Soumya, wait. Partho, no. Okay, Partho. No,
I told no question, we can go ahead.
Okay, sure. Okay, Bimal also say all good. Okay, thank you for have a good understanding so far. So let's move on. Okay. So so far we came to know what is big data, what are the different characteristics of big data, right? Then we saw parallel processing architecture. Then we saw how distributed processing came into picture. Okay. Then we saw how distributed system evolved and become Hadoop. Okay. Then now we'll see the Hadoop, the Hadoop distributed processing, the advantage or the features of Hadoop distributed processing. Okay, so there are mainly three different features. One is the scalability. Scalability means like when we upgrade or downgrade the system configuration or the hardware ratios, it doesn't affect the current or ongoing process. That is, there is zero downtime. Okay, there is only one point of failure, that is if the name node fails, then the system fails. That we'll discuss in detail when we go into it. Okay, but as of now, just understand, like the Hadoop distributed file system, right, or the Hadoop distributed processing, there is no failure of it. Okay, there is no downtime of it. Okay, so normally in a traditional system, when we upgrade, we need a downtime, right? We go offline, then we apply the required hardware upgradation or downgradation, or in software upgradation or degradation, like what software new softwares we apply, then we reboot it, then the system come online. But those things are not here. Okay, they have taken those challenges into consideration while developing it. Okay, then availability. So this is how, like when there is no downtime, that means it's high availability, right, and high fault tolerance. Any system, any part of the system goes down, it doesn't impact to the others. Okay, and there is very quick recovery of it. Okay, so those are the, like, and storage, like it can store a very high volume of data with the cost appropriate to its usage. To its usage means, like when we process a huge volume of data, we should not spend a very high budget to process it, right? So it should be very economic to process the data, so that when our return of investment should be high. Okay, so those are the main advantage of Hadoop distributed processing. So Samvit, like few time before you asked a question, right? Then why we are not using Teradata or Netezza? So these are the things, like the cost is very cheap. Okay, and the even Netezza or Teradata, the fault tolerance is not that high like this system. Okay, so if the Teradata system goes down, right, so all the fault tolerance is at the hardware level. Okay, if the hardware anything happens, the whole system will go down, because it's a total whole APEC of system. Okay, and you cannot do anything, like those are like vendor specific. Their people only will come, they will fix it, they will not even allow you to touch the box. Okay, so but here you have everything ready to use, ready to debug, ready to implement on your way, the way you want. Okay, that's why people prefer more this open systems. And this Teradata, when they built, or Netezza they built for a specific purpose only for data warehousing or BI system, like to do the data analysis, but not for a general purpose computer. Okay, so that's why, though they are very fast and they are responding very fast, they deploy the MPP architecture, but the cost is very high. Okay, that's why we are not using it, or we are not open to use it. Okay, then we'll go with the generation of Hadoop. So slowly we are approaching to Hadoop. So try to like concentrate more and ask more questions, so that from the beginning only we can cover as much as possible. Okay, so generation of Hadoop. So first, when they released it, right, they released it with the MapReduce version. So the first generation of Hadoop is called generation 1, which is having the MapReduce version 1. So the MapReduce version 1 or the generation 1 Hadoop, it has a limitation, like the total nodes, the total number of nodes of the computer, its support is like 4096 or 4096 computer max it can support. Okay, beyond that it will not support. So in generation 2, they overcome that limitation, and they come with a more improved controlling process called yarn. Yet another resource negotiator will look into detail what is yarn, okay, in next session. But yarn is like a more like a resource control, or what we call a scheduling, dynamic scheduling mechanism, okay, where they implemented in top of MapReduce. Okay. Then in current market, right, we have different distributions are available. On top we have Apache, which is open source, and they don't charge anything, but the drawback is there is no support. Okay. So it cannot be enterprise level. If any enterprise they build this, then they have their own, they have to take the risk of the support. If anything goes down, nobody will be there to support you. Okay, or if anybody support you also, that will be, the turnaround time will be very high. Okay, so we don't prefer to go in the enterprise level. So the same Apache Hadoop, right, different vendors they customized on their own, and they released with their own name. First thing is Cloudera, that or we call like CDH, Cloudera Distributed Hadoop, which is like a company called Cloudera, as we saw, like the people from Apache, they came and they customized the Apache Hadoop, and they released the name called CDH. It's a commercial version. So they don't charge for the setup or infrastructure, but they charge for the support. Okay. So any problem encounters, they will help you to resolve, and they will, the turnaround time is very very quick. And like it's now leading, one of the leading market product. Okay. Then the next market product is called Hortonworks Data Platform. So this is like developed by a Hortonworks company. Okay. So few of the Indian, they found it. They have they are the founder of it, and they started from Bangalore. Okay. And later on, like it moved to Silicon Valley. So it's a second top product in the market, and now the way it's growing, like after, we are expecting after a few years, right, it will cross to Cloudera also, because like Cloudera is going to its own proprietary one. Okay. But Hortonworks, they tied up with the open source. Okay. And they released, and they say like ODP, Open Data Platform. They call Open Data Platform. So all open source will maintain a specific standard or their own compatibility with all the product. Okay. So Hortonworks will have maximum open source compatibility, which is a good for enterprise, because they will get all the open source product easily available. At the same time, Hortonworks will provide the support for them. Okay. Then the next one is the Mapr. Mapr, like initial time when Cloudera started, Mapr also started, but slowly the market sharehold, right, Mapr is slowly going down, and because of like Hortonworks and Cloudera, they captured like most of the market. And but Mapr, like they don't charge for the system, but they charge for the support only. And the good thing Mapr is like everything is open source, documentation, huge list of documentation videos are there to learn, but their market share is very low. Okay. Then Microsoft HD Insight. Microsoft has released their own Hadoop, or like called HD Insights. Okay. Hadoop Distributed Insights, which is very not that much famous, but a lot of small players, they have implemented it, but they charge for both platform setup and support. Okay. The problem is they'll charge to set up your infrastructure, and those are very costly infrastructure, and again the support also very costly. Then Hadoop for Windows, this is one of the flavor released by Hortonworks again. They released a newer version called Hadoop for Windows to compete with Microsoft, and which is like in commercial now, and they charge for the support and they charge for the OS, Windows OS. Because the Windows OS again they purchase it from Microsoft only, but it's a, like this product also gaining the market share slowly, so it's a good to use it also. Any questions so far? Are we clear? So we know what are the major Hadoop distributions available in market, right? Guys, are we good?
Yes, yes, good.
There's a question from Sambit. Can we install Hadoop for Windows laptop? Can we install Hadoop for Windows laptop? Yes, it's available. Yes, Sambit, it's available. Any more question? Any more question? So Sambit, when you say Windows laptop, see the Hadoop distribution which comes, right? Though it's a Windows OS only, but the Windows or the operating system kernel is different. The kernel for the this Hadoop distribution is a Linux kernel only. Microsoft, they use the Linux kernel. On top of it, they made it compatible with the Unix, Windows operating system. Okay, so the whole OS is totally different than what we have the normal our Windows operating system. But yes, we can install it. So there is a question from Asis, which is the most popular distribution in market? See, in market now, still Cloudera has maximum share, but Hortonworks is growing, and there is no difference from operation or execution point of view. Okay, if you have worked on one system, you can work in other system very well. Sambit is asking, means we need to have VMware. See, Sambit, the execution mode is different. Okay, so there are different execution modes in Hadoop. Like we have sudo mode, we have standalone mode, and we have distributed mode, fully distributed mode. In the sudo mode, you may need a VMware, because VMware, what it will do, it will create a separate JVM for your each name node or data node. Okay, that's why you need a VMware. But when you go for a fully distributed mode or a single node cluster, which is a single one machine, you no need to have a VMware. So the only difference is a file system among all distribution. Ashish, sorry, I couldn't get your question. Okay, can you please brief on various distribution modes? Yes, in the next session we'll have. Yeah.
Can you hear me?
Yes.
Right now you told there is no difference in the distribution like Cloudera and Hortonworks. Okay, so the only difference is the file system what they are using, like in Cloudera there is a
no. Everybody, they use the Linux operating system, and
okay.
On top of it ext 3 or 4 file system. Okay, and they will have the HDFS on top of it. The only difference is the ecosystem. Which will cover on next session. We'll see they have built their own customized tools to interact with HDFS or to interact with the MapReduce framework, that is different. But the native file system is same, the commands are same, everything is same. Okay?
Okay, okay, got it.
Thank you.
Thanks.
You're welcome. So Somya, like we'll cover in the next session on all these distribution mode of executions. Okay, where we'll show like what is standalone, what is fully distributed, what is pseudo distributed. Okay, all these modes we'll cover. Any more question? I'll move forward. Okay. So we saw like Hadoop now, right? Now we got a very very high level knowledge on Hadoop. What is Hadoop, right? Hadoop is nothing but a is a storage plus processing solution to handle the big data problem, right? So this storage and processing, these two parts, these are the two essential parts of Hadoop, right? So the storage, when we say, as I said, they have their own file system called HDFS, Hadoop Distributed File System, which actually handles the storage problem. Okay, and the processing problem, which we'll discuss in the next slide. Okay, so before that, let's look into the what is HDFS, okay, or called Hadoop Distributed File System. So today we will only learn the terminology on HDFS, but in the next session we'll have a deep dive session on HDFS, where which will look at every corner of HDFS and we'll play with some of the commands on the HDFS, and we'll see how the data gets stored inside a system. Okay, so for today's understanding, right, just remember a HDFS, right, it's a like layer of the layer of file system which sits on the native file system of a computer. Okay, so I have here let's say I have here, right, all these data nodes are here, right? Okay, so I have all these data nodes are there, right? These are the data nodes, I have it, right? So all these data nodes, right, what they do, they have their own local disk. Okay, when the data are stored, a chunk of the file are stored in one disk, another chunk in this, another chunk in this here. The file is splitted into chunks and stored into the local disk. Okay, so there is another file system on top of this, okay, on top of this, which is called HDFS, which will have a global view on these files or the chunk of the data. Okay, so this file system, this new file system or HDFS, what we call HDFS, will have a global view on this file system where the data blocks are residing, how to retrieve all these data blocks and publish as a single file. Got it? Got it? What is HDFS? HDFS is a file system, distributed file system, which has the capability to store and retrieve the data in a distributed platform. Okay, so here we'll see what it says, like each data node is a part of HDFS cluster. Input data is stored in HDFS, spread across data nodes and replicated. We'll see all this, what is replication and data nodes, we'll see in detail. But for your understanding now, just to understand, a HDFS is a logical file system which is built on top of the native file system and which can have a global view on this native file system to find out which data blocks are stored where, or when a new data block comes, how to store the data blocks in different nodes. Okay, am I clear? Am I clear? Guys, am I clear? Okay. So now to maintain that global view, right? How it achieves? So it has different in a Hadoop distributed system, right? In a Hadoop distributed system, it has different components. The first component is called name node. Okay, name node, or it's called a master node. Master node means this is the master. He has to direct to its subordinates to work and control their work. Okay, in simple term, name node or master node. The data nodes are called slaves or work node. Okay, they actually perform the actual work. Okay, and when a new file comes, the name node, okay, what it do, it split the file and keep the block of data into each data node, and it maintains a reference to the data. Okay, maintains a reference means it maintains kind of metadata, which block stored in which node. Okay, and there is specific algorithm and there is specific rule how to decide which data will reside where. That will look into detail in next session when we go into the HDFS in detail. Okay, so as of now, just keep in mind, in HDFS or in Hadoop, we have a node called name node. What is a node? A node is nothing but a computer which can have multi-processor, a RAM and disk. Okay, so that node will be the point of entry or point of exit, single point of control. Okay, so name node is the center of HDFS. Okay, it keeps track of all metadata information of a split file. Okay, it keeps track of all metadata information of a split file. When a file is splitted to store into different data nodes, it keeps the track of metadata, means which block of data stored at which location. Okay, the address of the data block location. So the file level storage information maintained on name node. Okay, so the name node maintains the file level storage. File abc.dat, it contains 4 blocks, 1, 2, 3, 4. First block stored in data node 1, second block stored in data node 2, third block stored in data node 3, fourth block stored in data node 4. So all this file level information it maintains, the name node maintains. Okay, and name node interacts with client request and solve them. Okay, so the name node interacts with the client request. Client request means the, like with the user, when we perform any task on Hadoop, we want to store a file or retrieve a file from Hadoop, we interact through a name node operation. Okay, in backend. So name node has a high configuration commercial hardware, because if the name node goes down, that means we don't have any point of control for the data node. We don't know where the data is stored, right? So name node is the single point of failure. It's called single point of failure. If that means Hadoop system will fail when the name node will fail. No other situation it will fail. Okay. So again, to overcome this problem, they have a secondary name node. Secondary name node is equal like name node. At any point of time, it will have a synchronized copy of the data in secondary name node. Okay. So as soon as the name node goes down, everything will taken with the secondary name node. The secondary name node will take the control of the job. The secondary node will already have the repository of the metadata, where which data resides where, and it will continue the process from there. Okay. So secondary name node, right? Now we have data nodes. Data nodes are often called as a slave node. Slave node means they are the slaves. They do the work. Okay. They do the work as per name node. Okay. So when a file gets splitted, the name node only store the metadata, which file name, which block, stored where. This information name node maintains, but the actual data stored in the data node. Okay, the actual data stored in the data node. So the block level storage maintained at the data node. Then all data processing are done by the data nodes. Okay, the disk which are used to store the data, they are local to the node, means they no need to have any network usage to process the data. Okay, so the main advantage of the Hadoop distributed processing is we are taking the computation to the data rather than the data to the computation. In general, in the traditional processing, what we do, we send the data to the computation resource to compute the data. But here, the computation goes to the data to do the computation. Right? So the network usage is very low. The name node and data node communicate each other by heartbeats. Heartbeats mean, what is the heartbeats? Like every regular interval of time, the data node will send a signal to name node, which will show the name node is active and working. Okay. If the name node doesn't receive continuous 3 signals, right, then it will think this data node is offline. It has some problem. Okay. So what it will do, it will assign the same task or the process to another node which has a copy of the data. Suppose let's say is dealing with this red block of data. Okay, it went down. Then it will see another red block of data in the same cluster is there. Okay, so it will assign the work to the second node on the same cluster. Okay, if the second node of the same cluster process the data, then it will take the result. If the second node also not available, then it will look for the different cluster on a different cluster where the same data is there. Okay, then it will assign the same process and same task to the data node and get the response. Okay, so heartbeat is nothing but to make sure the data nodes are available. It constantly receives the signals to the name node. Okay, then balancing. Balancing means, like as we said, like this Hadoop system are horizontal scaling. Horizontal scaling means we can add more systems, right? So if we already have 5 systems and we'll add 5 more systems, then this 5 system already they are occupied with like 80% of the data. The new 5 system which we added, they'll have like data imbalance, right? Data imbalance means in this 5 node we have a high volume of data, but the new 5 nodes will have low volume of data, right? So that's why to redistribute the data, when new node get added, there is a balancing script runs which actually redistribute the data to make sure all the nodes are equally occupied. Okay. Then replication. Replication means when a data block are sent to data nodes, right, it makes sure based on the configuration parameter determine how many replication it has to do. The default replication is 3, okay, and default replication 3 means it will keep 3 set of the same data, okay, and there is some algorithm which will go through. What it will do, it will first determine which which is the node is available. It will keep the first copy. The second copy of the same data it will keep on the same cluster, okay, on a different node. The third copy it will keep in a different cluster in a node, okay, so that in a cluster failure also it can have the third copy available, okay. So this is the Hadoop file system or HDFS, a very high level, but we'll look more into detail in the next session, okay. Just now we are acquainted with the terminology, what is name node, what is secondary name node, what is data node, what is heartbeat, what is balancing, what is replication. Okay, got it? Any doubt? Any doubt, guys?
No, Balaji.
Thank you. Okay, so I'll move to the next session. Okay, I'm moving to the next session. Let me take the arrays. Where is the arrays? Okay, so we talked about the name node, then secondary name node, then data node, and the heartbeat balancer, all this, right? So those are like first generation architecture, okay. We have a second generation where the yarn has been introduced, right? Yarn tool has been introduced, right? And we have shared edit logs. Shared edit logs means like any changes to the data are maintained, okay, in active name node or standby name node, okay. And we'll look into, we'll study in detail in the next session what is a container, what is a node manager, and what is a node manager, and what is a resource manager, okay. So I'll just give an overview, okay. Resource manager is a global process which monitors the resource usage of a node, of all the nodes in the Hadoop, okay. Whereas node manager manage the resource and obey the direction of the resource manager to restrict the resource on a container, okay. On a container, what is a container? Any idea? If anyone has worked on the security systems, they might be aware of it. What is a container? Container is nothing but a bundle of resource, okay. Maybe some computation resource, some memory, and some network, okay, and some priority. So containers are used for fair scheduling, to enable the fair scheduling, okay. Fair scheduling means based on the priority, based on the resource model, a job will decide how much resource it will take, okay. Node manager responsible for initiating the container and restricting the resource at the node level, okay. And resource manager is responsible for global view of the resource, okay. And it has to decide the scheduling mechanism, it has to decide the resource restriction on a node, okay. So that's called the yarn architecture. These all are very high level, we have seen, okay. We will, when we go into HDFS next session, we'll deep dive into each and everything, okay. Got it? Any question? Okay, I'll move to the next one, okay. Next one is like we saw the storage architecture, right? Now we'll see the process architecture. So in the process architecture, the two main things are, one is job tracker, one is job tracker, another is task tracker. Okay, one is job tracker, one is task tracker. The job tracker, it runs in the master node. The job tracker, it runs in the master node. Okay, what it do? It split the input data, schedule and monitor the task. Okay, the task tracker, what it do? It keeps communicating with the job tracker. It execute the task and send the result to the job tracker. Okay, got it? Any question? Any question so far? Okay, fine. So I'll just summarize what we have learned so far. Okay, so first we have seen the big data definition. We have seen how to define a big data. Okay, then we have seen the different characteristics of big data. Then we have seen in real time how these characteristics we identify. Okay, then we have seen the computer architecture. Then we have seen how the distributed processing came into picture. Then we have seen the evolve of distributed processing. Then we have seen how Google file system came into picture. Then we have seen how distributed file system came in, distributed processing, Hadoop distributed processing came into picture. Then we have seen the major component of Hadoop distributed processing, the storage, which is HDFS, the processing, which is job tracker and task tracker. Am I clear? Am I clear? Good. So next session, right? I would say you people go over the material and do some research, learn more things. Okay. Next session we'll have a quick a recap session where we'll have a quiz sort of thing. Okay. I'll ask some of the quiz which will answer based on your understanding. You can answer it. Okay, quizzes. Then after that we'll move to HDFS and the MapReduce. Okay, so next session we'll finish HDFS and MapReduce. So next session our topics would be deep dive into HDFS. Deep dive into HDFS, we'll see in detail HDFS, we'll execute. Does veracity practically come into picture when we consider our system that are planning for migration from traditional data warehouse to HDFS? Soumya, to answer your question, no. Veracity comes into picture when we are identifying a source of data. Okay, before we select a source of data, we have to think the veracity, like how much useful data we can extract from a source. Like example I said, right? Suppose we are taking some of the words from Twitter. Okay, so you have to realize how beneficial or how much useful information you can get out of it. Okay, and to answer your question, traditional data warehousing system and HDFS, these are two different terms. Okay, we never should mix both of these. Okay, traditional data warehousing system cannot be migrated to HDFS in any way. Okay, data warehousing system should be there in an organization on its own space, but Hadoop will be there also with a different space. We'll discuss when we see the difference between data warehousing system and HDFS. This is one of the topic actually I thought of to include, but next session I'll include it and I'll show it how it is different. Okay. Are we good? So next session, the not exactly migrating, but when we are planning to accommodate huge data and do BI on it. No, in your data warehousing, BI or data warehousing is all known element. Okay, there is no unknown element. So there is no question of veracity. Right?
Okay.
In your traditional data warehousing, you keep all the information in the form of either fact and dimension, right? So all the fact and dimension are known subject, okay, known subject, and their I would say dimension data are the like qualifying to the known subject, okay.
Okay, I think we'll like Balaji will end here today. So like regarding the next session, we will do it sometime next week, and I will publish the timings. So if we can hear some feedback also on the timings, please email to me and Balaji. Or if you have any feedbacks for this session, you want to be done something different, please email to me and Balaji. He is copied in the email also, which I sent it to everyone. We can take it from there. And regarding timings, I will shoot out an email soon, maybe tomorrow or by early next week. We will do a session next week. So we will try to do it in the weekdays in your morning time, maybe do 1 hour session each. So will that work for everyone? Like in this, having 2 sessions next week, 1 hour each on the weekdays.
So you're saying IST weekdays, right?
Yeah,
Sorry,
yeah.
IST morning. IST morning.
Yes, IST morning and EST night time. Let's say in this 10:30 to 11:30.
Yeah, that will be fine. I think so.
Okay, so thanks everyone for participating today. So we will see you guys next week.
Right. So like guys, like we need a honest feedback. Like if you want to improve any sort of thing, right, in the either in the material or in the topics you want to include, right, feel